Hi everyone! Today we're going to talk about angled projectiles. These are similar to horizontal projectiles, except that your initial velocity, where in horizontal projectiles was only in the horizontal direction, here your initial velocity will have both an x and a y component. Okay? So angled projectiles is where the object is released with both a horizontal and vertical velocity. So steps you need to take to start solving this problem begins with the initial velocity will need to be broken up. Broken up into components, which will be v initial x and v initial y. And you're going to do this using, of course, SOHCAHTOA. Using SOHCAHTOA. Okay? So, some things you should keep in mind at maximum height. Remember that v final y will be still 0 meters per second. And if an object returns to its original height, then we know that the time up equals the time down, and that the v final y is equal to the negative of the v initial y. Okay, so we're going to be using all of these to solve a problem. So let's look at the problem now. Okay, so here's the problem. A ball is launched with an initial velocity of 4.47 meters per second at an angle of 66 degrees above the horizontal. How long does it take to return to the original launch height? What is the range? And what is the maximum height the ball reaches? So remember, the first thing we have to do is break up this angular vector to its x and y component. So here's your ball. It's going in this direction at an angle of 66 degrees, and I need to find the x and y components of this. So this will be my v initial x, and this will be my v initial y. This is my v initial. And so my v initial x, I will use cosine to find this, will be 4.47 cosine of 66, and my v initial y will be 4.47 sine of 66. And so for this I get 1.82 meters per second, and for this I get 4.08 meters per second. Now, once we have found the initial x and y components, we no longer need the 4.47 value. That is no longer valuable for us because it's angled and we can't use it. So once VI is broken up, you no longer use it. Okay, now the first question, how long does it take to return to the initial launch height? Here's what we know. Returning to initial height means that v final y is equal to the negative of v initial y. Okay, so if I have something, it goes up, it comes back down. My initial y velocity and my final y velocity have the same magnitude, but they have different directions. So we're going to use the equation v final y equals v initial y plus a yt. So this is the y direction only. Plugging my values in, since my v initial y is 4.08, my v final y will be negative 4.08 equals 4.08 plus negative 9.8 times time. Solving for time. And once you plug this in and you solve for time, you will get 0.83 seconds. That's how long it takes for it to go up and come back down. The next question says, what is the range? Okay, so I know for range, I always use the same equation, and that is delta x equals vi x, vixt. So in this case, delta x equals, my vix is right here, 1.82. A lot of students make the mistake and they use 4.47. Remember, we no longer use this number because we've broken it up into its components. So I'm going to use 1.82 as my vix. And now that I found the time here, I'm going to use that time, 0.83. And hopefully you're doing the calculations by pausing and getting an answer and then comparing it to mine. So this will be 1.52 meters. And then the last question says, what is the max height the ball reaches? Let me get a little box right here. So we know something at max height. We know that at max height, v final y is 0. It has to stop before it can come back down. So we're going to use the equation v final y squared equals v initial y squared plus 2ay delta y. Since my max height v final is 0, I'm going to plug in 0 here. My v initial y is 4.08, so 4.08 squared plus 2 times negative 9.8 times delta y, and I'm solving for the delta y. And when I plug this in, I get for delta y 0.849. Okay, so again, same idea as the horizontal projectiles. The only difference is that now you have an initial y velocity. You will need to break it up, get your x and y, and then go from there.